Hello, chemistry class. It's Mr. Feynman. Happy Wednesday to everyone. I hope you're doing well. It is Wednesday. How do you like that? We made it to Wednesday. Um, I want to sort of jump right in here because I don't want to make you spend too long listening to me talk. You have better things to do. So, first of all, hello. Second of all, a reminder how this works for your grade. The way I'm doing it, and most of you figured it out, not everybody's there yet. You're going to get two Google Forms on a standard day. We'll mix it up. It won't be the same thing every day. But the standard will be that you have two Google Forms. One of them is like a check for understanding, and it's multiple choice. Take it as many times as you want, but make sure that you ace that. Make sure you get to 100%. And if you're not sure how, ask around. Ask each other. Ask me. 2 to 4 are my designated office hours, but you can ask before then. I'll be off and on and trying to answer emails when I am able. The only question is when. 2 to 4, I am literally sitting at the computer waiting to hear from you. But other times during the day, I can help you. Don't just guess. Don't just guess. The second assessment, I want to see you apply what you did in the first assessment. So don't just guess. Don't leave it blank. Take your best shot. Explain what you did. When I'm grading this, it's a combination of did you do it and did you do it well. And if there's one mistake, that's fine. You're going to get full credit. If you made a mistake and you explained your work, then that's good. I can work with that. I sent everyone an email last night. Hopefully you got it. I've never done this before using something called mail merge. And basically, when I have a spreadsheet like I do every time you do a Google form, I get your answers in a spreadsheet. It takes forever to write a separate email to each one of you. But what I can do is type in a spreadsheet my response, and then Gmail takes care of all of the emailing. So I did that for the last two problems, the ones that were math. We're going to do some more math practice today with dimensional analysis. Some of us nailed it. Some of us knew when to multiply, when to divide, and many of us did not. And so that's fair. So that's what we're going to work on. Number 3. Video chat is now audio chat. There were some concerns raised, which makes sense. So I will not be looking at what's behind your camera. Okay. I still want to use Google Meet because the audio is great as a channel. I have the setting on my side set that I receive audio only. I don't know if you get a message to that effect, but I have it set so that I am only listening to you. I am not looking at your camera. You can also turn off your camera. That's one of the options in Google Meet. At the bottom, there's a little camera icon. Click it, and it'll turn to the no camera icon. So that's a double way. But I don't, I don't want to look into your whatever. That's fair. So I can still share my screen with you if there's something that I want to show you visually as well as audio. So we're gonna do that for the time being. Questions 4, 5, and 6 right now. Pause and answer all three. Ready, set, pause. Okay, the answer for number 4, how many atoms in a mole of silver, is Avogadro's number, 6.02 times 10 to the 23rd. It's a very, very, very big number. A mole is a medium-sized amount of stuff, but it's a huge number of atoms because atoms are so small. That was the big takeaway from yesterday's lesson. I hope you got that. Number 5, how many atoms are in a mole of carbon? It's the same answer. How do you like that? 6.02 times 10 to the 23rd. How many molecules are in a mole of water? It's the same answer. Water's a compound, so we don't talk about an atom of water. The smallest piece of water you can possibly have is a molecule. It's really small. It's H2O. It's 2 atoms of hydrogen and 1 atom of oxygen is a molecule of water. But there are 6.02 times 10 to the 23rd of those in a mole of water. Okay. Let's take a look at the assignment from yesterday. How many atoms are in a mole? Just about everybody knew. 6.02 times 10 to the 23rd. What's the name for that? Avogadro's number. Why would scientists want to use such a large number? This one, a lot of people mixed up. Many of you said for accuracy and precision. No, 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 no. We use a large number because atoms are so small, because there are so many of them, because that's how you can count a huge number of things by using a mole. Uh, Using a large number doesn't make it more accurate, doesn't make it more precise. And so that was a common answer, and I wanted to address that. There were lots of interesting facts in the video. I like that. But these last two, we had some trouble with these. Okay, so you got individual feedback. Hopefully you got that and it makes sense. Please let me know if it doesn't make sense. But we are going to practice solving problems like this because sometimes you multiply, sometimes you divide, and you can memorize what to do, or which some people like that, most people don't, or we can do dimensional analysis. So here's what we're going to do. Dimensional analysis. Do you remember dimensional analysis? I hope you do. We're going to review it. The basic idea is that we're converting units by multiplying fractions. You get to pick what those fractions are, and so that's some of the trick is to knowing what to put and where. So there's key rules. First of all, identify the given unit that's given to you in the problem. What do you know? And the goal unit. What are we trying to find out? When we start, I like to write the given over 1, just so it looks like a fraction. Okay, if you look at online sources, they don't always do that. It's not required. I like to do it so that it looks like a fraction. Then we're going to multiply it by another fraction, but you pick that fraction. 2 rules for that. First of all, the goal units in the numerator, the given units in the denominator, because they're going to cancel. That's what we do. We want to cancel out the given units so they're not there anymore. We will have the goal units. Secondly, the total numerator and the total denominator in this fraction must be the same. So we're going to practice with that. Are you ready? Here we go. How many atoms are in? This was the exact problem that was in your work. And some of you got it, some of you didn't. So I'm going to set this up with dimensional analysis. Here's my gallery of things that I can drag here. So I start with the given over 1. Given is moles of gold. Okay, so I just put that over 1. Okay, this isn't so difficult so far. Now, what's my goal? My goal is how many atoms. So I'm going to multiply this by a fraction. I start with a blank fraction. Okay, blank fraction. And I want the given unit in my numerator. So atoms of gold there. The goal unit in my denominator, moles down there. Okay, let's stretch this more. Okay, so I got that. Now I need to put the numbers in so that the top equals the bottom. I know that 1 mole is equal to Avogadro's number of atoms. So I'm going to put 1 mole at the bottom there equals Avogadro's number of atoms right there. Okay. Now I can do the math, and the math says when I do multiplication of fractions, I multiply my numerators. My denominators are just 1, so that's not a problem. So I just take this number times that, and I get my answer. Okay. Let's do another one. This time, this is the second problem. If I had 4 quadrillion silver atoms, how many moles would that be? This time, the given is atoms of silver. The goal is moles of silver. I'm going to set it up the same way, but it's going to wind up different. How do I do that? Start with my given. Here's my given over 1, just like before. Given over 1. Okay. Times a blank fraction, just like before. And you can do this, right? You don't need me. You can do this on the practice items. So we have blank fraction, and I want, again, this time I want my goal unit to cancel, or my given unit to cancel, so I put atoms of silver down there and moles of silver up there. Okay. What numbers go where? 1 mole is the same as Avogadro's number of atoms. So 1 mole in the numerator, Avogadro's number of atoms in the denominator. This time, when I do the math, I'm going to get my numerator is 4.10 to the 15 atoms. Oops, 4 times 10 to the 15 atoms of silver. But my denominator, my denominator is 6.02 times 10 to the 23rd atoms. Right there. Okay. So I'm going to take this number and I'm going to divide it by that number. And when I do that, I got to use my scientific notation in the calculator. Okay, that's that double E key. If you're not sure how to do that, please, 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 please ask. All right, that's how it works. You have 2 assignments. Make sure you ace the first one, then you do the second one, and we will have a wonderful day. Please be in touch. I will see you later. Take care, folks.